Good day, everyone. My name is Dinesh Daniel, and I am here today presenting my final year project, which is titled Design, Fabrication, and Testing of a Food Cart. My supervisor for this project is Dr. Terence Lala. These are some of the key areas this presentation will focus on. We begin with the background. Firstly, this project is a continuation of work started by a previous student of the university, Mr. Varun Maharaj. He was also under the supervision of Dr. Lala. Since this project has already been started, a lot of areas in the product design development process have already been done, which include the selection of external design, research methodology, SWOT analysis, pest analysis, Porter's five forces, failure mode effect analysis, SolidWorks simulation of the external frame, as well as financial analytics such as activity-based costing, net present value, profitability index, discounted payback period, have all been conducted. What is the issue at hand? This student identified an overwhelming issue faced by the student population at the University of the West Indies, St. Augustine campus. The student noticed limited and difficult access to food at UWI. This diagram illustrates a map of the area. Within the outline is the university's main campus. There is one food court which is located at the southern end of the campus, which is highlighted. This therefore makes it challenging for those at the northern side and environs to acquire food. Additionally, the food court serves a restricted option of food with constraints in opening hours and is often overwhelmed by a large crowd, especially during lunch period. This can now be portrayed to a national scale with the effects of COVID-19 pandemic as persons are looking for food with easy convenience. Now as the background is understood, we can now develop the problem statement. As illustrated, at the present time there is a need for convenient, low-interaction food source due to COVID-19 pandemic. As a result, the creation of a mobile food cart is proposed, as this can provide meals accessible to customers throughout the country, starting with the student body at the university. The food cart is to be operational throughout the day, serving breakfast, lunch, and dinner. The project is funded by the University of the West Indies and is to be operated by their staff along with anyone who wants to rent a cart. Therefore, what is this project set to accomplish? What are their objectives? The four objectives are listed here. Project scope. The scope of this project is to continue existing design and construction of this food cart and develop the internal layout to increase its versatility and efficiency. As previously explained, currently there is a need for convenient, low interaction food source. But what does this mean? How can our food cart achieve this? We can do this by meeting the following criteria. The cart must be cost effective, meaning it is relatively cheap to produce and operate. It must require little and inexpensive equipment in order to operate, and maintenance costs should be low as possible. The cart must be versatile, as it must serve various types of food, and should serve food for breakfast, lunch, and dinner. The cart must also be able to provide food wherever needed, whether it be in or out of the campus. The rise of COVID-19 pandemic showed the importance of attaining food with little physical contact with persons or the environment. To do this, my project will work hand in hand with our colleagues Jim and Lala. He is creating a food app for the food cart whereby food can be ordered and paid for online. Therefore, all persons need to do is collect. In an ideal situation, there should be no waiting times and no contact with anyone. The research conducted were on four main topics: the regulation to be taken into consideration, layout to assist in utilizing the space in the most innovative ways, insulation and panels as the frame will need to be enclosed and proper materials need to be used, and lastly, patent reviews of existing food carts. Under the regulations, certain aspects were taken into consideration. These were wiring codes, lighting design, specifications, health and waste disposal. Licensing and financial analysis was also conducted by the previous student. Project plan to be completed. The building of the external frame first needs to be completed. This also comprised of modifications to the previous design. Secondly, data is to be collected in the form of e-questionnaires, interviews, and research. This should give us an understanding of user requirements for the internal design of the card. Thirdly, concepts of the internal layout should be generated and the final design should be chosen. This also includes the design of the electrical and plumbing. Chosen designs can then be tested in simulation. Installation of the internal components will then be done, followed by the finishing of equipment, after which the card should be fully operational. Real-world testing must then be conducted. Lastly, analysis of the food cart must be done to ensure it meets all requirements. Recommendations for improvements can then be made. Included in this section is some of the data retrieved from the e-questionnaires. These data are essential to the development of the design criteria and key attributes. Question 3 can be considered one of the most important questions. This is so since it gives us an idea of what foods will be cooked. From this, we can have an idea of what equipments are needed and how the space will be used. The major foods that will be cooked in our food cart is shown to be grilled, fried, or boiled, and the least popular being baked. This question aims to tell us what type of space to prioritize along with how much is needed. Priorities will be given to the workspace along with space for operating small appliances and space for storage of small cooking items such as seasoning and utensils. Sponsors have indicated that the cost of design should be a key attribute since this is preferred over the demand of mobility. Therefore, the design should be cheap to produce while maintaining the ability to be mobile, as a significant number of responders, 37%, still choose flexible locations. Question 6. Although there is a slight greater demand for renting our car rather than purchasing, the margin is so close, 53 and 47% respectively, that we must design for both scenarios. Designing for rent means that the cart layout must allow quick turnover. This means the card must be constructed in a way that can be cleaned, decluttered, and tweaked in a timely manner. This demand for purchasing requires the design to be easily reproducible, with little waste and little skill set required to manufacture. This question gives us an idea of how fast the card is expected to be ready for another customer. The shorter the rent period, the easier the card should be to be prepared. It also gives us information of how rent packages should be created. By this data, daily, monthly, and yearly packages should be offered as it is desired by customers. This question 8, aims to deduce the expertise and financial stability of potential customers. Since majority will use our food cart alone, it solidifies the point that our design should be cheap and easy to use since this cart will be occupied by persons with little experience within a kitchen. Analyzing the data from potential customers and conducted additional research, the following criteria was developed as the key attributes for internal design. Comfort refers to the ergonomics of the layout for the ease of operation. It measures how well workers are able to utilize the space with ease without obstructions. It also takes into consideration lighting, spatial arrangement, ventilation, and other human factors. Cost incorporates direct and indirect costs associated with building and maintaining the food cart. Functionality is how well the space is used. This takes into consideration how spaces can be multifunctional as the food cart is required to be versatile. Safety ensures the design conforms to all standards and is arranged in a way to prevent all foreseeable mishaps. Maintenance is necessary since the cart should be long-lasting and suitable throughout its lifetime. Maintenance comes in two parts, minor and major. Ease of manufacturing, just as maintenance, affects the cost of the cart. If the cart is easily reproducible, less skill and time is required. A pairwise comparison chart was conducted to compare the importance of each criteria. It was found that the safety was one of greatest importance, followed by functionality of the cart. Concept generation. Three concepts were generated based on the user's needs and key attributes. The floor plan of concept A is shown. Although each floor plan is unique, there are some things that all concepts share. The height of all countertops is 1 meter. Under all the countertops exist shelves, which can act as storage or working space to use small appliances such as blenders and microwave. This provides the cart necessary space for those appliances, while still maintaining a clear countertop for working space, as required by question 4 of the analysis. Fridges are located under the serving counter. Two fridges. A stove was chosen as this is the most versatile cooking apparatus. However, the space left for the stove was 1 meter, although a smaller countertop stove may be used. This is so since the average width of an oven is 1 meter. Therefore, if needed in the future, our oven can easily be added in this space. This design is more intricate and requires a higher level of skill to produce and maintain. It prioritizes function and workspace. The countertop is split into two workspaces and made specifically for the cart to be managed by two operators, one to carry out the task of the kitchen and the next to serve customers. Similar to Concept A, this design is based on an open floor plan. However, instead of counters running right around, there is a 24-inch gap on one wall. This gap changes the entire dynamics of the cart. It mitigates the wasted space formed on either side of the stove in Concept A. By doing this, a more usable counter space is achieved, and the cart can be considered to have a clockwise flow. This is so as food can be prepared starting at the countertop, the sink area, which is then moved in a clockwise direction to be cooked. The cooked meal can then be arranged in the right side of the stove and placed in warmers. After that, the food is ordered and dished out and distributed to the customers. Next, the occupant's hand can be washed and the process can be repeated. This offers a less chaotic environment with high efficiency. A probe chart was made to select the best concept. Each concept was compared with each other and each key attribute was rated, with 1 being the least and 3 being the best for that attribute. As seen in the table, Concept C had the highest overall score and was chosen as our final design. Engineering drawing was then developed to manufacture the internal framing of the design. This was followed by electrical and plumbing designs. The figures above shows the isometric views of the internal frame. The figure on the left shows the frame and materials which needs to be added to the external frame. Essential bracings and shelves are not shown in this drawing since those items already exist in the external frame. The figure on your right shows the internal frame attached to the external. First, we will look at electrical design. This design features 6 bulbs and 6 double-socket outlets powered by a generator. Calculations conducted show that a minimum of 2 bulbs were needed in a bright environment and a maximum of 7 bulbs could have been used for maximum brightness in a dark environment. To save electricity, 3 bulbs are connected to each switch so that 3 can be used in bright environments but 6 can be used only when needed. Outlets 1 to 3 are placed there for the use of small appliances since this is the working area. Outlet 2 is to be placed in the shelf below so that appliances can be used in the shelves and not only in the countertop. Outlet 4 can be used to give power to electronic devices such as cash registers and monitors. Outlet 5 is to be placed on the floor of the car to provide power to 2 refrigerators. Outlet 6 is placed on the counter and can be used as the operator sees fit. The generator was sized and found that it requires a generator with a minimum 6.5 kVA. The blue lines on the plumbing design indicate clean water and the green shows waste. The supply water will be placed near the top of the cart so the water will flow using gravity. The wastewater storage is placed at the bottom of the cart for the same effect. This mitigates the need for a pump. Simulations are run using the maximum remaining weight that the cart can uphold, assuming that all this weight is due to appliances which should be placed on the counters. This weight is 700 pounds, which is over the recommended amount for a countertop to withstand. All 3 tests shows that the internal frame was well designed. Simulations also produced a factor of safety for counters. This was found to be 11, which shows the design can be optimized to save material and therefore cost. The process began with the image on the left. The right image shows the external framing complete at the start of the floor, which was done in December. These pictures illustrate the completion of the external framing. The next step of the construction is of the internal component. This picture shows the finished internal framing and the current state of the cart. The counters need to be covered with plywood followed by stainless steel sheets before furnishing. Findings and discussion. This project received funding from the University of the West Indies in the form of $30,000. $16,150 was used by the previous student. $13,850 was left. The countertops required approximately $1,460 for the purchasing of materials. Therefore, a remainder of $12,390 is left, approximately, for the purchasing of appliances and decoration of the car. These costs can be reduced further with optimization of design and manufacturing process to reduce waste materials and material usage. The weight limit of the cart was 1650, which is a maximum towable weight of a TIDA. The trailer was rated to support a weight of 1720 as seen in the nameplate. The proposed weight of the external frame by the student was 1633. This was reduced to 463 pounds by modification of the frame. The internal frame had a weight of 90 pounds, making the total weight of the cart 533 pounds. This leaves 697 pounds for the furnishing of the cart and 400 pounds for 2 occupants. Additionally, the tests conducted showed that the internal framing was a bit over-designed, factor of safety of 11. Therefore, materials can be reduced. The internal counters took 4 days to build. This is from the cutting of materials to have it welded and ready to be covered. This can easily be reduced to 2 days by commercializing the process. This also illustrates that the cart can be easily manufactured. We will look at the limitations or problems encountered in this project. The biggest factor that caused this project to be delayed and incomplete was the COVID-19 pandemic. Firstly, the construction was started late due to the lockdown of the country. When started, I could not have been present on campus, which caused a delay in communication and in turn delayed results. Simple requests or issues of the manufacturing process, which could have been taken a few hours to solve, had I been there to guide the technicians or could have worked instantly to rectify, took days. Furthermore, then restrictions were lifted to a certain extent. I was allowed to come into campus. However, this time was during midterm examinations, so I was only on campus after my exam or the days I did not have any. Additionally, technicians were busy with students on the campus, so the card could not have received their full attention. So therefore, time was also an issue. Secondly, there were long gaps and wait to start the internal frame due to lack of material. Additionally, the completion of the countertops could not have been done although there was time for it, since the plywood was not present. This was also affected by the pandemic. Weight and cost of the cart had always been a concern. All designs and changes made were worked around this factor, since the cart needed to be mobile and low cost. Lastly, the existing limitation was seen as a limitation of the previous design. There were a lot of innovative ideas that would have saved material and make the cart easier to reproduce, but had to be disregarded as the main structures of the frame were already welded. Recommendations. My first recommendation is a study on the use of renewable sources, mainly solar and wind, to be used to power the car. The cost and weight of this technology and batteries should be considered to evaluate the feasibility of making the switch. Secondly, research should be conducted into an alternative design of the frame where the door is located at the back. This will allow for two straight counters to be built instead of two curved ones, making the manufacturing process less complicated, saving time and money. Due to time and cost constraints, the cart was not insulated. I recommend that such is done to improve the comfort within the cart. There's a lot of additional safety measures that can be put into place, one of which is the use of non-skid floor in the cart. This can be done by simply covering the floor with a rubber mat. Ventilation can also be added in the form of another window or gap in the roof. An extractor fan can be placed over the stove also. A step can also be added to enter the cart, as currently the cart is 2 feet from the ground. This may be difficult to reach for some persons. Lastly, research should be conducted to properly evaluate how the food app can be used to market this unique cart and its touchless service. To conclude, the outer frame of the cart was completed. The internal components were designed and laid out. The electrical and plumbing designs were produced. The counters were tested in simulation. The cart is very near completion, and if given attention and equipment sourced, it may take a maximum of 2 weeks to complete. Then this prototype can be tested in the real world and optimized further. Thank you for listening. I look forward to any questions at the interview stage.